Hi folks, this is Checkpoint Quiz 8.7. We're presented with a system of nonlinear equations, and in Part A we're asked to make a rough sketch of the system, ostensibly to help us figure out how many solutions to look for and where they could be located. So let's look at that first equation, y squared plus 4x equals 9. Thinking back to Chapter 7, I know this is going to be a parabola because only one of the variables is squared. To get it in the standard form, I'm going to move the x to the other side and factor out the leading coefficient of the x. So when I factor out that -4, I'm left with a 9/4. So this tells me the vertex is at 9/4, 0. Since it's the y that's being squared, and we have a negative coefficient of x, it's going to open to the left. So this is 2 1/4 is where the vertex is, going to open this way. To give us an idea how wide it is, let's see what the y-intercepts are. If I zero out the x, I would get y squared equals 9. That gives me y equals plus or minus 3. So that's the sketch of the parabola. What else do we have here? The other equation, x squared plus y squared is 5. Once again, thinking back to Chapter 7, that's a circle. The center's at 0, 0, and the radius is square root 5. Now, how do we approximate the square root of 5? Well, the square root of 5, unfortunately, is also something a little bit bigger than 2. And so this is where the issue lies, is, depending on where 9/4 compares to square root 5, and without using a calculator, it's difficult to figure that out. If the center's here at the origin, we got to go a little bit more than 2. So is it going to be a little bit inside of this, a little bit outside of this? Okay, so it's tough to know exactly what's going to be happening. We could intersect it at 2 points. We could intersect it at no points, depending on if it cuts through or not. So regardless of what happens, though, it appears as if the intersection points are going to be in the first quadrant, which means the x value we're going to look for is going to have to be positive. Okay, Part B, solve the system. Check your answers algebraically. So when we encounter a system of nonlinear equations, we fall back to either substitution or elimination. Is it possible we can multiply one of these equations by a number so that when I add it to the other equation, we can get a variable to drop out? In this case, we can. The only y term up here is y squared, and that's the same as the y term down here. So I can go ahead and multiply the first equation, both sides, by -1, just like we did back in section 8.1. So I get -y squared minus 4x, -9. X squared plus y squared is 5. I can go ahead and add those equations up. The y's drop out. I get x squared minus 4x equals -4. I turn that around and I get x squared minus 4x plus 4 equals 0. I factor that. It turns out to factor extremely nicely, and I get x equals 2. So now that I have x equals 2, I need to figure out the y's that go with it. So it doesn't matter which of these equations I go back and plug in x equals 2. So we're going to plug it back up into here. I get y squared is 1, which means y is plus or minus 1. So the solution I get 2 points. The x-coordinate is 2, the y-coordinate is 1. The x-coordinate is 2, the y-coordinate is -1. Okay, let's check our answer. How do we check the answers? How do we check the solutions? Well, just like with any other system of equations, we have to plug the value x and y into each equation and show that each equation holds. So I plug in x is 2, y is 1 into the equation y squared plus 4x equals 9. So 1 squared plus 4 times 2, does that really equal 9? Well, 1 plus 8 sure does equal 9. So it works in that equation. Now I have to check it in the other equation. X squared plus y squared equals 5. I substitute in x is 1 and y is 2. 1 squared plus 2 squared, does that in fact equal 5? Well, 1 plus 4 indeed equals 5. So 2 comma 1 works. Now we got to go and check the other solution, 2 comma -1. Alright, to check 2 -1 into the first equation, we substitute -1 in for y and 2 for x. Once again, 1 plus 8 does in fact equal 9. We plug it into the other equation. Plug in x is 2, y is -1. And once again, 4 plus 1 does equal 5. So that's solving the equation and checking the answer algebraically. So that does it for number 1.